Hey guys, so in this video, what we're going to do is we are going to be sketching graphs of sine and cosine. Now, in the last video, we did the base graphs. We just did sine of x or cosine of x. Now, in this video, we're going to figure out how to handle if your equation or your function has a bunch of other stuff attached to it, right? What if sine is multiplied by something? What if your x is multiplied by something? What if there's an addition or subtraction within the parentheses here, within the argument? What if we add or subtracted off something at the end? And same thing with cosine. So how do we now graph these transformations if our amplitude, period, phase shift, and vertical shift are different than they were in the base graph? So first off, some definitions, and then we're going to see how each one of these pieces actually affects the graph. So k, so here's our base equation of both sine and cosine, and these are the only two functions we are going to work with today. So our general form is k plus a times sine of b of x plus c, and same thing for cosine. Notice these are the same. The only thing that's changing is the sine and the cosine. The k variable controls the vertical shift. So how far up or how far down? The original base graph of sine or cosine is shifted. The absolute value of a, so a could be positive or negative, but we only care about its absolute value. That's the amplitude. That controls basically how stretched out or flattened our graph is going to get. This b piece right here has influence over the period, or how long the graph takes to repeat itself. And then phase shift is what the C, actually C and B, have control over. And this is basically just horizontal shift left or horizontal shift right. So let's go on to a live graph and see how each one of these variables affects our sine and cosine graph. Okay, here in the Desmos software, we can see we have a sine graph and a cosine graph. And right now, K, A, B, and C are all set so that both of these graphs are just the base equation. This is sine of x. This is cosine of x with nothing else added in. Now, each one of these little sliders, as I play with them, they're going to change the K, A, B, and C in here, and we'll visually see how these guys actually affect our graph. So K, remember what was K? K was vertical shift. And look, as I play with it, as K gets bigger, my graph, my whole thing, everything stays the same. I'm just literally lifting the whole graph up. K goes back to 0. We're unchanged. K goes negative. The whole thing just goes down. Negative K, positive K. Positive K lifts, negative K lowers. Okay, so K just lifts or lowers the whole thing. But everything else remains unchanged. So let's put K back to 0. Now what about A? A was the amplitude, right? A kind of controls stretch, is what we'll call it. So as a gets bigger than 1, it's set at 1 by default. As a gets bigger, look, both graphs are stretching. Red is sine, black is cosine. A gets bigger and bigger and bigger. Look, it's like somebody took the graph and started to stretch it out. Let's put a back to 1. And now notice as a gets less than 1, what happens? Between 0 and 1, it gets flat. So if a is between 0 and 1, our graph flattens. And even negative, if a is between 0 and 1 negative, our graph is also flat. And then look, as we get past 1, we start to stretch out again. So that's what a does. Set our a back at 1, where it belongs. There we go. And now b. What is b in control of? Now b helps influence the period of the graph, or how long the graph takes to repeat. So as b gets bigger than 1, notice everything's scrunching up, and the period is getting smaller and smaller, smaller period. It almost looks like a coil, right? Put b back to 1. Now look, as b gets less than 1, between 0 and 1, our period gets really, really long, right? Super long, and even negative. So b between 0 and negative 1 also stretches out. And then as we get high negative, look, it compacts. Again, our period gets really small. Okay, so b controls the period. The higher b, whether it's positive or negative, the smaller the period. The smaller the b, especially at any point between 0 and 1, the more stretched out it gets. And then we have our C variable. What is our C variable control? C variable helps with phase shift, which you can think of as just a horizontal, the whole graph shifted over left, or the whole graph shifted over right. So a C, as I'm moving C, look, you can see it just looks like rolling waves. The whole graph is shifting left, or the whole graph is shifting right. As C gets negative, the graph shifts right. As C comes into the positive, the graph shifts left. So basically think of it as a horizontal shift. Think of C as horizontal shift. Think of K as vertical shift. Let me put my C back to 0. And everybody's base graph again. Also notice, cosine, which is in black, starts at 1, goes 0, -1, 0, 1, right? And then it repeats. Sine goes 0, then 1, then 0, then -1, then 0, and then it repeats. That fact is going to come in handy. All right, let's go back and start graphing these things. All right, so to graph these things, we want to have some kind of method, recipe, algorithm, because we don't just want to like always keep making tables and graphing the table of values, even though that works, and it will work every single time. And if you like using that method, just keep doing it. But this will be a little bit faster, right? We always want to do things quicker, more efficient. So here is our method. So we're going to be given an equation of either sine or cosine. And the first thing we want to do is identify these properties. We want to say, okay, what's the phase shift? Okay, what's the period? Okay, what's the amplitude? Okay, what's the vertical shift? And if we remember, all of these were dependent on the variables in the equation. So after we identify and pluck those out of the equation, so we'll have a list like, okay, well, we know all these properties. Then on the x-axis, we're going to label the starting point, which is going to be the number that we get once we calculate phase shift. The end point, which is going to be equal to the phase shift plus the period. So we're going to have to do a lot of adding fractions here. And then the midway point, and then we're going to also label the quarter points as well. So when we're done, we'll have a start, a finish, a midway, and then quarter ways too. So at the end, we'll have 5 points. Then we're going to label the y-axis with the opposite amplitude. So if my amplitude is 5, I'll label 5 and -5 on my y-axis. If my amplitude is 7, I would have 7 and -7 on my x-axis, or sorry, y-axis. And then I'm going to go ahead and sketch the curve in question. So remember, sine will start at 0. It'll go 0, 1, 0, -1, 0. Okay? Except for my 1s and -1s are going to turn into what my amplitudes are. And we'll see this. Cosine starts at 1, it goes to 0, then it goes to -1, then it goes to 0, then it goes to 1 again. Except for 1s are going to be substituted by whatever my amplitudes are this time. And then we'll extend the curve. We'll keep repeating the curve to the right, to the left, because these guys are infinite if we would like to graph more cycles. So let's see examples. So let's graph 3 times sine of 2x plus pi over 2. So again, let's pick out our pieces. So 3 is my A, 2 is my B, and pi over 2 is my C. So what do I need? I need amplitude. So my amplitude is equal to 3, so that's the easy one. My phase shift, remember, is -c over b. So in this case, -c is -pi over 2. -pi over 2 over b, which is 2. So my phase shift then, -1/2 divided by 2. If I cut a half and a half, I get a fourth. So -pi over 2 divided by 2 is going to give me -pi over 4. Okay, I got my phase shift. I need my period. My period is 2 pi divided by b. So I got 2 pi now divided by, what's my b? My b is 2. So my period here is pi. All right, I got all my pieces, and there's no vertical shift here because there's no k being added on anywhere. So I'm clear on vertical shift. All right, what's our next step? Our next step is to plot points along our x-axis. So first, plot the phase shift point, -pi over 4. -pi over 4. Next, plot the endpoint, and the endpoint is going to be equal to phase shift plus period. So this point here is going to be phase shift. Here's my phase shift plus period. How do I add negative pi over 4 with pi? Well, it's just like adding fractions. So I'm going to change this guy to 4 pi over 4, right? Make an equivalent fraction with the same denominator. Negative 1 pi plus 4 pi, 3 pi over 4. So this ending point here will be 3 pi over 4. Okay, I need to mark the midway. So midway between these guys is going to be here. And what value is that going to be? Well, if this whole distance was pi, right, halfway through will be pi over 2. So I add together again, like I said, this is going to be a big exercise in adding fractions. I'm going to add negative pi over 4 with pi over 2, or basically negative a fourth plus a half. We have pi over 4 here. This piece here will be 0. So plus pi over 4, plus pi over 4, plus pi over 4. What's pi over 4 plus pi over 4? Well, it's 2 pi over 4, better known as pi over 2. So now I've plotted my beginning, I've plotted my end, and this is where I got this number here. Plotted my beginning, phase shift. My end, phase shift plus period. And then figure out, okay, well, what's halfway between? Okay, what's a quarter? What's halfway between? What's halfway between these guys? What's halfway between these guys? And you're going to end up 1, 2, 3, 4, 5 markers. Okay, so we got our x-axis all taken care of. The next is the y-axis, amplitude. 3 and negative 3. So the amplitude you mark out opposite. So if it's amplitude's 5, then 5 and negative 5. Amplitude 6, 6 and negative 6. Okay. Okay, and now I graph the function in question, which is sine, and I'm going to use the fact that sine starts at 0. So sine starts at 0 and then goes to highest amplitude, and then goes to 0, and then goes to lowest amplitude, and then goes back to 0. So that's why knowing the shape of the sine curve is so important. It goes 0, high, 0, low, 0. 0, and I'm going to try to connect this as best I can. 0, high, 0, low, 0. Again, sine, 0, high, 0, low, 0. That's for sine. Cosine has a different shape. So this then would be the sketch of our complete cycle for 3 sine 2x plus pi over 2. And here's a better sketch of the graph. So we can see here our pieces that we have, right? Here is our beginning. Here was and this was the cycle that we graphed right here, which is between these two guys. So that's 1, that's 2, that's 3. See, there's our amplitude. There's our amplitude, and we can see the sine shape, and it looks like we did a pretty decent job of getting that right. And then if we wanted to extend it left and right, we could. So now let's do a cosine example. So we're going to do a similar thing, it's just we're going to use the cosine shape now. So let me pick out my A, B, and C. A is 3, B is 2, and C is negative pi over 3. Okay, got all my A, B's, and C's. B, there we go. A, B's, and C's. My amplitude is equal to 3. My phase shift is equal to negative C over B. So in this case, negative C would be positive pi over 3 over B, which is 2. Well, I'm cutting a third in half, so then I would get a sixth. So this is going to give me pi over 6. So my phase shift is pi over 6. My period is equal to 2 pi over B, so 2 pi over B is 2. So my period here would be pi, okay? And again, no vertical shift because there's no plus k at the back or no k at the beginning. I'm not adding or subtracting in anything here, so I have no vertical shift. All right, let's mark out our x-axis, which is what's going to take the most amount of time here. So my starting point is my phase shift. Starting point is what I got for phase shift. Ending point is phase shift plus period. Phase shift plus period. So I need to add pi over 6 and pi together. Think about this as I'm adding 1/6 and 1 together. I'm going to change this to 6 pi over 6. And that's going to give me 7 pi over 6. So that's how I figured out what my ending point was. Again, phase shift plus period. And then I need to mark the halfway point. And then I need to mark the quarter points too. So I need to figure out what these are. So basically I'm going to be adding pi over 4, adding pi over 4, adding pi over 4, adding pi over 4. So you just go over here and do some quick scratch work real quick. So pi over 6 plus pi over 4. Do some equivalent fraction work, right? So this will end up being 2 pi over 12 plus 3 pi over 12. Think of it as adding a 6th and a 4th together. So I get 5 pi over 12 here. All right, so it's 5 pi over 12. All right, I add another 4th. So now I come back. Okay, I got 5 pi over 12. I'm going to add another pi over 4. Okay, so times 3 times 3. So that would be 8 pi over 12. 5 plus 3 is 8. That's where it's coming from. Okay, divide by 4, divide by 4. Divide by 4. Divide by 4. So I'm just reducing. That's all. Okay, add another pi over 4. So now I come over here, go 2 pi over 3 plus pi over 4. Okay, so I'm going to change both of those into 12. So times 4 times 4 times 4 times 4 times 3 times 3 times 3 times 3, right? Common denominator. 8 plus 3 is 12. Or sorry, not 8 plus 3 is 11. 11 pi over 12. Now this is 11. Okay. Whew, got it. Okay, so I have my x-axis now all marked out. Like I said, that's what's going to take you the most amount of time because it's a lot of fraction work, as you can see here. And then, okay, we need our amplitude. So our amplitude is 3, so we're going to use a positive 3 and then a negative 3 because we don't have a vertical shift. All right, now the fun part. I have cosine. Cosine goes 1, then it goes 0, then it goes -1, then it goes 0, then it goes 1. Okay, which is why we mark out 5 points. 1, 2, 3, 4, 5. So again, but instead of 1s, I'm going to switch out my 1s now for 3s. So I'm going to go 3, then 0, then -3, then 0, then 3. That's where amplitude comes in. That's what it does to the 1s. It multiplies each one of your y values by 3. So I start at 3, and then I go to 0, and then I go to -3, and then I go to 0, and then I go to positive 3. And that's why cosine looks like this kind of cup shape, because it starts high, goes low, and then comes back to high. Oops. Also, your phase shifts matter, so don't draw things like that, because this was our first point. So this needs to be 3, this needs to be 0, this needs to be -3, this needs to be 0, and this needs to be positive 3 because we had a phase shift. I drew it without a phase shift, which is why my graph looks so funny. And there we go. So our graph starts at pi over 6, our cycle ends at 7 pi over 6, and we have our U-shaped cup here. So let's look at a better drawing. So here we go. So here is our phase shift. As we can see, what we drew is we drew from here to here. Right, phase shift, this was phase shift plus period. Our amplitude here was 3 and -3, and we can see kind of a better way than I drew that we have our kind of U cup looking shape. And we go in 3, then we go 0, then we go -3, then we go 0, then we go 3 again, okay? All right, let's do one more, and let's this time throw in something with a vertical shift in it. And this will be the last example that we do today in this video. All right, what do we have for variables? We have a k now. Here's our a, here's our b, and here's our c. Okay. The way that we're going to deal with the k is we're actually going to deal with the k at the end. So I'm going to take down all of these, and then I'm going to toss the k in at the end. I'm basically going to be like, okay, well, here's what our graph would have been, and then let's lower the whole thing by 5. because our k is negative 5. So our k is negative 5, which means the whole graph, we're going to tank it down by 5. Our amplitude is 5. Our phase shift is negative c over b. Negative c is negative pi over 4 over b. B is pi. If I'm taking negative pi over 4 and I'm dividing it out by pi, negative pi over 4, dividing by a fraction is the same as multiplying by its reciprocal. So look, pi is canceled. So negative 1/4 is going to be my phase shift. My period, 2 pi divided by b. So for this case, we have 2 pi divided by what's our b? Our b is pi. 2 pi divided by pi, pi is cancel. Our period is going to be 2. So notice for this example also, we're not doing things in terms of pi anymore because our pi's are gone. So we're going to use just regular whole numbers. So our phase shift is negative 1/4. That's our starting point. And our ending point is phase shift plus period. Phase shift plus period. So this point here is going to be period plus phase shift. If you add 2 plus negative 1/4, let's convert. 2 is 8/4 minus 1/4. You will end up with 7/4 here. So again, get really, really good at fractions. We need a halfway mark, and we need quarter marks as well. So the whole thing is 2, right? Which means halfway then is going to be 1. So negative 1/4 plus 1, that'll give me 3/4. This will give, if I cut this in half, this will give me 1/4. Cut this in half, this will give me 5/4. In other words, look, I'm adding plus 2/4, plus 2/4, plus 2/4, plus 2/4. Why? Because 2/4 is a half, and if I cut 2 into 4 pieces, I would get 1/2. So I'm out a half, out a half, out a half. Amplitude is going to be 5, except for what I'm going to do now is I'm going to enact the fact that our k is negative 5. So our amplitude would have been, I would have marked a 5 and a negative 5, right? But because we're downshifting, I'm going to downshift. So now the tallest point on my graph is going to be 0, and the lowest point on my graph is going to be negative 10. This would have been 5 and negative 5, but I'm shifting everything down. So now the tallest point on my graph is going to be 0, and the lowest point on my graph is going to be negative 10. Okay, I have a sine function. So sine goes 0, 1, 0, negative 1, 0, except for I have my amplitude, so I would be going 0, 5, 0, negative 5, 0, and now I enact my k, so I'm minusing 5 from everybody. So how are my y values going now? I'm starting off at negative 5. 5 minus negative 5 is 0. 0 minus negative 5 is negative 5. Negative 10, and then negative 5. So see, here's how to enact phase shift with your y values. So because of k, so without the k, this would have been my y values. Because I'm shifting everything down 5, then what I'm doing is I'm taking all my y values and I'm subtracting 5 from them. And now here are my new y values. So my first point is going to have a y value of negative 5. First point, y value of negative 5. So let me do this in a different color. Y value of negative 5. Second point, y value of 0. That's my second point, though. Second point, y value of 0. Third point, y value of negative 5. Third point, y value of negative 5. Fourth point, y value of negative 10. And then fifth point, y value of negative 5. So I start down, come up. Wow, that's probably one of the best ones I've drawn so far. So here is the graph, negative 5 plus 5 sine pi x plus pi over 4. And this is how to enact the phase shift when you're, sorry, not the phase shift, the vertical shift when you're graphing. Take what your y values would have been. So here's original sine. This is sine of x. y values. This is 5 sine of x, y values, and this is 5 sine x plus k, which is -5 sine values. So this is how the y values shift around as we transform our graph. So let's look at kind of a better version of this. So here we go. So these are both graphs, and what I have here is I have them shifted. So the blue graph, this would have just been 5 sine of pi x plus pi over 4. The red graph is the whole thing. And as you can see, the red graph is just the blue graph shifted down. Everywhere it's shifted down by 5. Everywhere shifted down by 5. Everywhere shifted down by 5. And you can see that's what the vertical shift down by 5. That's what the vertical shift has done to our original graph here. So I know graphing is a lot and it's a long process, but my suggestion to you guys is that you go out now and practice. The more graphs you do, the better you'll get, the more automatic it'll be. You'll be able to automatically find phase shift, period, amplitude, and vertical shift right away. You'll get quicker at it. You'll get quicker at plotting your x-axis points. You'll get quicker at recognizing, like, oh, sine, 0, 1, 0, -1, 0. Oh, cosine, 1, 0, -1, 0, 1. Right? Everything will just get quicker. So my suggestion is go out, practice, practice, practice. I'll see you guys in the next video, and as always, if you guys have questions, please don't hesitate to ask.